Well, welcome everyone to a very special and slightly delayed live event. Apologies for keeping everybody waiting. Today marks a very special supply chain collaboration between ESSCA and Lokad. My name is Conor Doherty. I'm a technical writer here at Lokad, and joining me in studio, Chaaben Kouki, Professor of Management at ESSCA, Ling, researcher from the Eindhoven Institute of Technology, and Lokad founder Joannès Vermorel. Now, before I hand over and we officially begin, I will briefly describe what will happen today. First, Professor Chaaben will introduce the key topics and explain the relationship between these two institutions. Then Ling will do a presentation. And finally, the three panelists will discuss the applications of artificial intelligence in supply chain. Following that, if you have questions, I will pose them to the panelists. So please submit your questions in the Teams chat. And if you have a specific question you want to ask to a specific person, please specify their name and I'll do my best to direct it to them. And on that note, I will hand over to Professor Chaaben. Please enjoy the event.
I'm happy to be with you today and to make a first presentation of this research seminar, which is dedicated to artificial intelligence and its application in supply chain. So the context, why we are interested in artificial intelligence in our school and why we should go onto this direction of the usefulness of artificial intelligence in education in general and in the research. So if you look at the school position, there are some facts that we cannot ignore. The fact that artificial intelligence will reshape the world in terms of benefit for business and also for the society. And you can see a lot of applications that have been appeared recently in 2022-23, like the famous ChatGPT and Google Bard and others. So we cannot ignore such fact. And also for education, if you look at the education level, you see that many institutions start to using tools to learn and to educate people in general, like Khan Academy and others. And also the last thing is that there are many reports that have been appeared in different consultant company like McKinsey and BCG and others, and all of them saying that artificial intelligence will be a competitive weapon for business in general. So again, if we look at the school, there are two pillars. We have teaching programs and we have research in general. And for teaching program, there are two axes. We have Master of Science, where we would develop the use of artificial intelligence in a different program. Even maybe we create different programs related to directly artificial intelligence, like a Master of Artificial Intelligence in our school, and also in the bachelor level, it's similar thing. For different labs that we have one which is behavioral and experimental lab, but we would like also to create a new data lab. We call it data lab and sometimes artificial intelligence lab. So what are the main missions of this lab? Of course, the first thing that we have to think about is to train faculty members, for example, to use these algorithms that have been appeared. Also to build empirical protocols related to languages or natural language processing and algorithm like machine learning algorithms. And of course, once we have more experience and more expertise, we can also provide services for companies. This is also one of the mission of these data lab. And of course, we organize seminars like today. This seminar is actually in line with the data lab mission. The idea is to bring researchers like Ling, and also we have to bring business in reality by inviting Lokad host us. But the idea is to sometimes we invite companies, sometimes company invite us, and try to see what happened in reality. So the position in terms of what we have to do in this data lab, this is a tree of artificial intelligence in general, but you can see most of things that have been already developed are machine learning and natural language processing. Of course, there are other things like robotics, vision, and so on, but we will focus on these two branches, like machine learning and natural language processing. There are sub-branches or sub-axes that we have to develop them in the future. Why we focus on this? Because simply there are many different trends in artificial intelligence. If you go, for example, to Google, you will see that most of people are looking for machine learning and chatbot like ChatGPT or others. Now, if you focus more in machine learning, you will find many algorithms or tools or techniques. And again, here you see the emergence, what we call deep learning or deep reinforcement learning. And this is the focus of today. We'll try to show you some use case on how to use deep learning in supply chain with the presentation that will come later. That's why we should develop both of them, machine learning and chatbot. Of course, there are others, like, as I said, vision and video and so on. So we start what it has been done to understand what we should gain as how can I say it, competition, and we should understand these two levels actually. For the projects that we have one project that already started with some collaboration with Italian universities. The one that we already sent it to a journal is called Performance of DRL, Deep Reinforcement Learning Algorithms, in Production Inventory System. The system that we consider here is as follows. We have a factory here. We have different warehouses that satisfy different demands. And the idea is to say, let us look at DRL algorithm and see whether they perform good compared to the classical approaches. The classical approaches are many. I will not detail them, but there are many, like base stock system, SQ system. This is expected value of perfect information system. It means that you don't make a forecast, but you take the expected value of the demand and see what is the performance of the system. A simple case. And here, PPO is proximal policy optimization. It's an algorithm which is a part of DRL. We have also a policy gradient and actor critic algorithm. So we compare them and we find finally that PPO algorithm is the best one compared to all existing algorithm, including those coming from DRL. We send this work in a journal and it's under review, and we get a first feedback, which is really positive. We have other projects that we still developing them, like this case, waste reduction using DRL for perishable inventory system. The idea is as follows: if you go to supermarket, you see that sometimes you receive or you have an offer of item with a small remaining shelf life but a lower price. And for a longer remaining shelf life, you have to pay full price. So the idea is how to allocate the demand based on this price and this remaining shelf life. We are looking at this. We're still exploring this, but we will get first results in the next coming months. We have another project which is also a collaboration with the real case with a company, BMS, Bristol Myers Squibb company. This company provides drugs, different drugs. You can look at the website that you will see what is BMS exactly. The idea is as follows, is to test one of the algorithms, which is PPO, proximal policy optimization, versus a human decision maker to see whether we can improve the decisions that have been already taken in the past. Of course, after that, we have to think about implementation, how we can implement the action taken by PPO, the decisions taken by PPO in the real world. So again, we're still exploring this. We have some preliminary results, which are really quite good. But for instance, we still try to implement some sort of decision tree instead of PPO for a human manager to be put it in a real case. Another project now we will detail it much more in detail. We'll give it much more in detail, which is the presentation of Ling. And it also concerns DRL, but now for dual sourcing inventory system. This project is in collaboration with Willem and Rolf from Eindhoven University of Technology. Thank you.
Evelini, I'm very glad to present this project. This project is about using deep reinforcement learning for dual sourcing inventory problem. So first, I will start with two important concepts. The first one is reinforcement learning. So basically speaking, it means that an agent interacts with the environment, and it aims to learn how to act in different states, and is aimed to maximum its cumulative rewards. And another important concept is the deep reinforcement learning. It combines the idea of reinforcement learning and deep neural network. Next, we will introduce the one important concept, Markov decision process. There are 6 important definitions. Environment, as we can see from this figure. The environment means the system we want to optimize. It includes all relevant information and elements for our study. And the state space, all the elements and information upon which the actions depends. An agent, it means an entity that maps a state or observation to an action. An action space, transition probability, and the last one is a reward. So now we go into detail of our project background. So it's continuous review dual sourcing inventory system with compound Poisson demand. So in this setting, we consider 2 suppliers. The first one is the regular source, and another one is express. So in our setting, the lead time of regular source is longer than the express. However, its cost is lower. So let me explain what's compound Poisson demand. So it means that the interarrival time between customers, the time follows the exponential distribution, and the demand of each customer follows a specific distribution, for example, geometric distribution in our study. So next, I will explain what is review policies. Let's take an example. We are the managers, and we need to decide the number of orders we need to make and when we make the order. So that's 2 important questions if we are managers. So review policies is to answer the second question, when we make the order. So the first classic policy is periodical review policy. The inventory status is tracked at a specific time interval time. And we track the status at a given time interval. So the action we made is triggered by the time. However, for continuous review policy, we track the status of stock continuously. Every time the inventory position falls below a given point, we will make order. So basically, these are the difference. So after we understand how we make action, we need to define the event sequence. So basically speaking, there are 7 steps we need to make. I will show this figure. It's clearer for us to understand. First, the demand is realized, and the current inventory is updated. And then we observe the interval time, and the current time is updated. And then based on the current state and the demand, we need to make orders, QR and QE. And then we update our state and current inventory level. And the last step is the corresponding cost is incurred, which including the holding costs, back order cost, and ordering cost. Before we go into the deep reinforcement learning algorithm, we need to introduce 2 benchmark heuristics or policies, which are already proven having good performance by many researchers. The first one is dual sourcing dual index policy. each dual index policy is also associated with two parameters, SR and SE. So we can calculate QE using the formulas. And for TBS policy, each TBS policy is associated with two parameters, R and SE. We place an order from regular source every R101R time unit. Here we finally goes into detail of proximal policy optimization. As Professor Chaaben already said, he introduced a little bit about this algorithm. So basically speaking, this algorithm almost performs the best among all the deep reinforcement learning algorithms. That's the reason why we choose to use this algorithm to solve our problem. So this is the general idea of this algorithm. So it's an on-policy method. The first, we need to collect sets of trajectories and compute values. And then we update policy, use clipped surrogate objective and pessimistic bound. And the last step is we update the value function. So finally, we need to define our own Markov decision process parameters. First, we need to define the state space. We define there are 4 vectors and the current level. The first 2 vectors are the QR and QE, which means the the number of products we order from regular source and the express source, and the relative time they will arrive. And here I show this figure. There are 2 approaches of implementing PPO based on dual index policy. The first one is the multi-discrete action space, and the second one is multi-agent. So as we can see from this figure, the states, we should note that the state space and the observation space, they might be different in some situations, but most of the cases they might be the same. So finally, the results. So this one is our configuration parameter setting up. We find that in PPO performs best in some situations. However, it didn't outperform TBS and dual index with their best parameters. So next step, we will try to improve PPO performance. The first one is we need to update the parameter setup because the performance of different algorithms, it depends on different parameter setup. So we need to pay attention to that. And another method we try to use is invalid action masking. So by using this method, we try to make the action of QR and QE, they are made not independently and simultaneously. We try to make them made sequentially. That happens in real life, which is reasonable. Here is the illustration of invalid action masking. Another point I want to mention is that there are already some researchers study the RL algorithm, for example, A3C, asynchronous advantage actor critic algorithm. They found that the DRL algorithm cannot outperform other heuristic policies, but they haven't found the reason. So we guess that this phenomenon doesn't happen by chance. Maybe it's related to the stochasticity and randomness of the demand and the interval time. So there are many unknowns waiting for us to explore. So thank you.
Thank you so much for listening to these presentations. As I said, we are with Joannès Vermorel, the CEO of Lokad company. And Joannès, I will just start with you. Can you maybe give us an overview what Lokad do exactly and how Lokad use artificial intelligence to to enhance benefit for their clients?
So Lokad, we are a supply chain analytics specialist. What we do is predictive optimization for supply chain purposes. What sort of optimization? We optimize supply chain decisions, essentially all the mundane, repetitive decisions. What do you buy? What do you produce? Where do you allocate the stock? Should you move your prices up or down? Supply chain is an immense game of super repetitive, quantitative decisions. So, so Lokad, what you do as a service is those supply chain decision making as a service. So people send us data, extract from their ERPs, and we return the results. And the way we do that, we typically refer to that as numerical recipes, and it involves a lot of what we call supply chain scientists, because it's typically numerical recipes that are fine crafted for every client. And then the techniques varies, and we could go into a lot of details, but there is probably too much to cover for this panel.
Do you have an example, a clear example of a use case or a situation before and after Lokad make its service?
For example, we had a client with over €1 billion of inventory, and in 2020 the lockdowns happens. They are in Europe, and we had 800 users that Lokad was generating the decisions, but supposedly they were supposed to validate the decisions. And it turned out that with those lockdowns for 14 months, the employees are not, so it was 800 white collars, they're not there anymore. They are at home, forced at home, and due to IT limitation, they could not connect to the IT company. But the company still operate 14 months without those people. So that's it. That's literally, you generate decisions that are basic, like what do you produce, what do you allocate, etc., etc. And so the question is that, we can have supervision, but with the lockdowns, we had grand experiments with more than a dozen of clients where they had their entire workforce that was like from home, but without the possibility to work from home for months. And while the activity was reduced for those clients, they were about 2/3 of their nominal activities, we did a grand experiment and it kind of worked. So that really begs the questions of, do you really need to have like an army of clerks? And there are many companies where now supply chain divisions have more people doing spreadsheets than there are people in the factories doing the stuff. So that really begs the question of, what exactly are you doing?
Yeah. Another question is related, again, we go back to the supply chain and its structure. We know that the most important input is forecast. So there are techniques which we call classical techniques of forecast. So what Lokad do exactly different compared to the classical method in order to get better result of forecast?
I believe there are three mortal sins. Things that if you do this mistake, it will prevent you from achieving any success. And they are all three, those big three, they are all variants of a very simple idea. It's very important to be approximately correct rather than exactly wrong. And there are three areas where it needs to be, you need to take that into account. And if you do those mistakes, nothing will work in terms of numerical recipes. I'm not even talking of artificial intelligence. I'm using on purpose the term numerical recipes to just say data in, result out, whatever happened in the middle. You can say it's intelligent, or just for my part, I would say it's just mechanical, but that's, a certain nuance just to emphasize. So what are those three big sins? The first is a super simplistic, naive version of the future. That doesn't work. So for example, if somebody tells you we want to do time series, bam, that's not going to work. So time series are dead. The future is not the symmetric of the past. So if you use time series, it's not going to work. Just an example. Let's say you're doing electrical equipment. You're a retailer of electrical equipment. In fact, you're selling pieces. So you would say, okay, I can have time series of sales for every product. But that's the wrong way to look at it. Why? Because actually, half of your business is not people who just come and say, I want to buy a light switch. It's a company that comes and say, I want to make a building. And I need 4,000 light switches all at once. And I order now, but I want this thing to be delivered 5 months from now at this date so that I can do my construction site. So you see, the future has a specific structure. There is expectations. I'm making a bulk order. I'm ordering 500 different references at the same time and expect them to be all available at the same date. So if you look at your time series, all of those sort of things, they're gone. They're toast. They do not exist anymore. So that do not work. I just gave you an example for a retailer of electrical equipment. Pick any other example, I will give you variations of that. So time series is, for example, the cardinal sin of those sort of super simplistic things that works in textbook, but never in the real world. So first, the future is not the symmetric of the past. You need to have like a non-naive vision of the future. At Lokad, that would mean probabilistic forecasting, but also high-dimensional forecast that takes into account all of those elements. And yes, it varies depending on the class. Second thing, second big mistake, if it's done, you're toast, is to think that you know what you want to optimize. You do not. Companies do not. And one of the textbooks, they say, oh, we are going to use this algorithm to do an optimization and whatnot. The classical mathematical optimization perspective assume that you know your optimization function. You know what you optimize. This is not the case. If you think that companies know what they optimize, this is not the case. They do not know. And this is very fundamental because people come and they apply a function. I say, you know what? I just did a calculation and whatnot. This is what you should optimize. But no. The reality is that the knowledge about what you should optimize can only come from the experience. So it has to be an experimental process to learn what you optimize. Question, what technology do you have to learn what you need to optimize? If you think your starting point is that you know the objective functions, game over, you're dead. So that's the second big thing. The third one is, and this one is really a killer, is to think that you can incrementally grow from simple models to more complex models. This is not the case. Not the case. And again, in textbooks, you will see plenty of people say, oh, we are going to do an inventory policy that can do it like this with just one SKU, and we add this and that and that. And people think that by doing it incrementally, simple stuff, you can grow into something that will deal with a real-world supply chain. This is not the case. Why? Because let's look at what a real supply chain look like. A real supply chain look like is driven by an ERP. The ERP is 10,000 tables. Each table has 20 to 200 fields. It is very complex. It was written 40 years ago by people who are dead. The semantic is gone. You have to find it back. There are rules that are hidden, buried. Sometimes the only way to know the semantic of a field is to ask the person, but what do you mean when you enter the field? Because obviously this person has an idea in his head, but this idea do not match the software documentation. So you cannot trust the documentation of the software to give you the right semantic. So bottom line is that, again, and that's all those three ideas are variations on approximately correct rather than exactly wrong. It is, you need to have something that can embrace such super complex environment, 10,000 tables, and gradually converge to something that is approximately correct and that will deal with the situation, and not try to have your, I would say, a pet toy algorithm that works in a simple solution that can potentially, that you think that you could refine to manage the complexity. No, it's the other way around. You need to have something that works with this gigantic complexity, and then you will start by being super approximate, but then you will refine into something that is slightly less approximate, but starting with a full complexity. Otherwise, you have something that is the syndrome exactly right, but it doesn't even start to work in practice. So that's the big three, and that's, I would say, most of the Lokad technology has been implemented with those sort of ideas in mind.
Another question, again, we still with Lokad. If you, for example, implement a solution for one of your customers, can you duplicate the same solution for other customers? Because we know generally algorithms from artificial intelligence should be maybe updated or take specific data of customers.
In supply chain, you're always extremely sensitive to the data environment. Each company is completely different. The companies, especially large ones, are the product of their history. They have gone through multiple series of M&A, merger and acquisitions. So you don't have like one ERP, you have like half a dozen. You have the old ERPs that have never been phased out. You have the WMS, e-commerce platform, the EDI, etc. I mean, usually you have like a whole landscape of applications. So there is not a chance when you move from one client to another that you will have the same landscape, not at all. And you're very sensitive to the exact semantic. Because, for example, just to give you an idea, a sales quantity, you would say, I have two ERPs. That means sales quantity should mean the same thing. The answer is no. For example, in SAP, sales quantity in some version means if it's negative, that it's a return. Okay, so now I have a columns where there is like non-homogeneous semantic depending on the line. So bottom line is what Lokad has done is to develop a programming language dedicated to the predictive optimization of supply chain. And when we start with a new client, we always re-implement from scratch. People would say, oh, it's insane to start from scratch. Say, yes, but no. I mean, no, because first we have to do it. Realistically, your data sets, your data landscape is completely different. So we are, and 90% of the effort is the data plumbing. So we need to have something that makes this part very, very swift, because what people don't realize with, I would say, data-driven projects is that 90% of the effort is the data plumbing. And so you need to have the technologies that makes this part super fast, thus a dedicated programming language. You absolutely need to have something that gives you high level of correctness by design. So for example, in terms of programming language that makes no late binding, Lokad was doing that 10 years ago. If you have a language that does late binding, let's say Python, you're dead. By the way, that's what happens to Lokad, because that means that you trigger an automated warehouse replenishment during the night, and bam, you get neural reference exception, or you get an array out of bound exception, or you get a disk quota exception, all sorts of things that are completely preventable if you have a programming language that gives you guarantees. In particular, you need to have something that also gives you guarantees at compile time of your calculation duration. So if, for example, the only way for you to know how much your program is going to last is to run it, you're in a very, very bad place. Because, for example, Lokad is crunching about globally, for all clients, more than a petabyte of data, of transactional data. So it's not images, it's not like videos, it's actually relational data that has a very, very high informational density. So bottom line, when you're dealing with terabytes of data, as it is the case in large companies, you need to have something that gives you guarantees, because you will start, let's say, a calculation at midnight, and at 1 a.m. you need to give this information to the WMS so that all the things are prepared, so that the trucks can go the next morning at 5 exactly on time. So you need to have this correctness by design. And so back to the initial questions, every client has its own implementation, but the way we do that to do it reliably and swiftly is through a dedicated programming language named Envision.
Another question is more philosophical or more general. If you look at supply chain in general, and you look at artificial intelligence development and revolution, how you see the future of that? Should supply chain apply more artificial intelligence, or should go to the classical methods, or what would be the future of supply chain?
So my take, and we have to really differentiate two things, because people, at least for the audience, they tend to confuse what I would say in the modern sense, logistics and supply chains. So for me, there are really two different problems. Essentially, let's say to clarify what I mean. If you're the logistic director, you are managing, let's say, a fleet of drivers. So you are on the ground, you're managing people, and you execute. So this is a science, it's a science, logistics, but it's a science about how do I execute something that is given to me. What I need to load in the trucks is given to me. Where the trucks are going is given to me. So it's just about making sure that people don't kill themselves by driving drunk, things. And there are plenty of physical hazards. It's complicated. It's very complicated. I'm not dismissive at that, but it is fundamentally about execution on the ground. Supply chain is about really the high-level decisions. What do I need to produce? When do I ship it? Do I need to allocate this quantity here or there, etc.? So it's fundamentally a white-collar activity. And the question is that obviously, supply chains have been digitalized for a long time. People speak of digitalization of supply chains, but it's a nonsense. For the last 3 decades, large companies in Europe had all their transactions are already in electronic form, and it's not new. It's literally when Lokad we tackle clients, the problem is not the lack of digitalization. The problem is that we have typically software systems that are so ancient that nobody knows anymore how they work. So that's very different sort of work. So, and for supply chain, when we say, can we automate those mundane decisions, I would say extensively. And right now, there are many companies, when you look at the evolution of the workforce, people for essentially a century had the idea that blue collars had to be optimized away. And we did absolutely fantastic progress. And for example, right now in supply chain, supply chain world, generally speaking, both logistics and supply chain, warehouses are getting automated. So now more and more warehouses are turning into one gigantic robot. So that eliminates all the people from that. We are left, so factories were essentially robotized 2 decades ago. Warehouses started to be robotized, I would say, 5 years ago. For most people, yes, at Amazon they had Kiva system 15 years ago, but for most companies it started 5 years ago. And then what we are left are truck drivers, and that will be automated maybe a decade from now. We don't know. But the number of white collars, so the people who take the decisions, has grown. And we have, I see many companies where literally you have now more people who deal with, that are essentially clerks dealing with Excel spreadsheets, than you have people on the ground. And that really begs the question of, does the supply chain of the future involve 20 people doing Excel spreadsheets for every single person that you have on the ground doing the stuff?
Yeah.
No, certainly not. And it's obviously there is like a good candidate for extensive automation. You can call it, artificial intelligence. Yes, we are not using this term because I think it's too loaded with so many expectations and whatnot. For me, it's just literally about just mechanization of those decisions. There is no grand insight. It is just about automation. And again, there is millions of those decisions that are taken every day. So anyway, those decisions usually are already automated, but just badly, with min-max settings that are just very rarely revisited. But they are already kind of automated for many companies, just badly automated.
Maybe last question related to, again, artificial intelligence. If I am a student in a business school, or let's say a professor that I don't have no background in this field of algorithm, techniques, tools related to, for example, coding in Python and so on. At your point of view, from which I should start? And should I start, or should I maybe keep it away?
So my take, I've been teaching for 7 years at university. My goal when I was teaching was always focus on what do not change. My goal when I was teaching was, am I teaching, I was, by the way, teaching distributed computing, software engineering for distributed computing. And I was thinking, am I teaching stuff that 40 years from now would still be valid? That was my point. And I was always asking myself, the question is that I am looking at something that is a fundamental, that will be still relevant 40 years from now. If not, not good. So you need to go to something that do not change. Because you see, the illusion is that you have a lot of stuff that keeps changing. This thing is not interesting. This thing is not interesting. What is interesting is the things that do not change. So right now, for example, let's say the proximal policy optimization. It's a long list of I would say reinforcement learning like optimization. There will be like 20 more, that will be discovered over the course of the 2 decades, of the next 2 decades. While I was, I started a PhD 2004. I never completed it. There has been like 10 algorithms that have been, incrementally revisiting the stuff. So obviously, there is no point, in getting a specialist of something that is just going away to be replaced by the next best thing. So that's the thing that are just going away. For example, but if you think about the fundamentals, linear algebra, basic algorithmic structure, what is an algorithm? What are the basic construct of modern programming languages? Those things will still be relevant. What does that mean to even think with a programming environment? Those things will not go away. What does that mean to be able to express your ideas with so little ambiguity that they can be turned into a program? You see, there is my take at Lokad is that if you already know I would say you have good ideas about what is an algorithm, what is a program, how does a computer work, memory, CPU, bandwidth, these sort of things. You can understand and learn those new stuff literally within hours. And on the contrary, people who are lacking those fundamentals, they can spend months and they are going to be lost. And for example, deep learning happened during my lifetime, like yours. Learning deep. I got interested in deep learning a bit late, 2014. When I did my PhD, that was in machine learning for computational biology. It was not there yet. I had learned about the old school neural networks, but deep learning is fundamentally something that depart quite extensively from those neural networks of old. It was to basically up my knowledge to the game. It was just a matter of days, not because I was particularly brilliant, but just because deep learning, when you look at it, it's just a combination of linear algebra, stochastic gradient descent, and tensor calculation. Exactly. All of those things, if you're familiar with those building blocks, it's literally hours to understand what is going on. It's not very difficult.
So we have to go to the basics.
And and that's, by the way, that's the things that when Lokad try to hire students, is I'm usually baffled by how little people know about the basics. For example, they go on the web, they don't know what HTTP mean. They go to a web page and they say, can you tell me what HTTP mean in your web browser? And they don't know. And then I say, what is happening when you type something in your browser and you see a web page? Can you just tell me roughly what is happening between what you're typing and the page that you're viewing? And then people have no clue. And you see, that's the sort of fundamentals. And I believe that for supply chain, this is the sort of things that you need to think. For example, not understanding the consequence of the speed of light. For supply chain, it's very important. You would say, oh, but things travel much slower than speed of light, so we don't care. No, we do care. Why? Because speed of light is actually quite slow. Speed of light, if you want to do back and forth across the globe, roughly speaking, in terms of IT, it will take, let's say, at the very best, 50 milliseconds. You would say, oh, it's plenty fast, 50 milliseconds. But if you consider that your ERP needs to talk to a system that is the other side of the world, and it needs to do millions of back and forth, those 50 milliseconds times 1,000 becomes 50
huge.
Seconds. Yeah. And then for 1,000,000 becomes 50,000 seconds. That's almost a day.
Yeah.
So you see, that's where if people have those fundamentals, they would realize, oh crap, we have a problem. The speed of light makes it that we can't do it that way. We need to do batching or something. And you see, and usually people lack those culture about those basic elementary things, such as the nature of the word, physics, and whatnot. And that's where I was trying to teach my students is to think about those basics, because I'm pretty sure that even 40 years from now, speed of light is still going to be a constant, Yeah. Even if we beat it somehow, it will take decades for this thing to really come into play.
Thank you, Joannès. I think we have to go to the questions.
Well, first of all, thank you everyone for your insights, and thank you all for your questions. Again, we could have put them in the chat, but you sent them privately to Alexei. I've tried to collapse some of the questions, so these are in no particular order, though two are actually specifically for you, Joannès. So first of all, open, whoever wants to answer. This is more or less, this is all very interesting, but most companies cannot afford advanced AI technology. Do you think Excel will thus continue to be a common supply chain tool? Chaaben, maybe start with you.
Well,
will Excel still be here?
Well, thank you. Thank you for the question. I think Excel still useful for maybe for many other years, for instance, because it takes time actually to adapt information technology and technology in general in different companies. There is a huge investment, and I think many companies still use this tool, at least for the next coming years. Of course, technology will maybe take a very huge part of the work that can be done with Excel, but my point of view is this. I think, for some years we're still using it.
Joannès, your take on Excel?
My take is that the usual discussion with a client goes like that. They say, No, I mean, we really cannot afford. Lokad is charging, let's say, for a certain company, 10,000 euro a month. You know, that's a ballpark. You can see our prices are public. So let's say 10,000 euro a month. They say, you know, we really cannot afford AI. I mean, 10,000 euro a month, I know it would save 50 people full time. And those people, each people cost me full employer cost 10,000 euro a month. But really, we can't afford it. You know, we can't afford those 10,000 euro. We have to pay those 50, 100 people to do those Excel spreadsheets. You know, we can't. So you see, I think people don't realize those technologies are immensely cheap, immensely cheap. So the question, I would say, can you afford not to do it? You see, that's a bit, you know, when people, that was a very famous quote from Edison. You see, I want to make the light bulb so cheap that only the rich can still afford candles. And that's the thing with AI. So the question is that the only people that can still afford not to do the AI will be the rich. That will be the LVMH of this world that are so crazily profitable that they can afford to do everything by hand because they are luxury. But if you're not like a crazy rich company, the question is that can you afford not to do it? Again, this is mechanization. Can you afford to stay on candles when you have light bulbs? You know, people would say, frankly, we can't do light bulbs. We have to stay with candles. Can you? Are you not getting the problem wrong? It is cheap. And there are many big vendors, I will not name, they are my competitors, that says, oh, AI, yeah, I mean, it's extremely expensive, 10 million euro to get started or you get nothing. No, this is just big vendor bullshit. Those things are cheap, dead cheap. I mean, most of the software code is actually open source. You have building blocks that are like dead cheap. And so, no, the answer is no. It is cheap.
All right, well, thank you. This is an education question, so I'll turn to Ling for you. As a university student, what skills do you think are the most important for future supply chain specialists to learn?
I think the most important knowledge we need to learn is the fundamental knowledge, just like he said. We need to learn the basic computer skills and the mathematics. For example, the Q theory and the linear algebra, and also the specific domain in supply chain. I think the computer science skills, mathematics, and the specific domain knowledge. I think these three things.
Well, thank you. And actually, Joannès, that then I guess turns back to you because we use a domain-specific coding language to solve supply chain problems. But for people who are not already experienced with coding and programming, what would be a good entry-level coding language, like C#, Python?
Yeah, pick any widely popular programming language. You know, that's the thing, is that it doesn't matter which programming language you pick as long as you pick something relatively mainstream. Again, there is for me as an employer, I see that we have at Lokad our own programming language. You would say, oh, but if people have been trained in Python, what about just recycling their knowledge? I would say what we recycle is not their capacity to program Python. What we reuse extensively is that they have started to format their mind toward the programming mindset so that they understand that in a computer, for example, a piece of text and a number are not represented equivalently. So those are the basic understanding, data types, these sort of things. So those things are more important. And when you know a programming language, any programming language, going to another is mostly a non-issue. Yes, for a couple of weeks, you will get used to it, but that's nothing. You know, people who are really, really good at any programming language can switch to another programming language toward weeks, especially if the environment is sane. Sometimes it takes years to kind of be able to work in an environment, but usually the problem is not the programming language per se, is the environment in which you operate that is like completely insane. And that happens. And then people say, oh, to be able to touch this thing, you need years of experience, but it has nothing to do with the programming language itself.
But again, you have to go to the basics to understand.
Yes, the basics. Again, you know, what is a string? What is a floating point number? Numbers in computers has a finite precision, so that means that things are not going to work as you think. It's basic things, and that will still be true 4 decades from now. Why? Because, for example, we could make numbers arbitrarily precise with computers.
Yeah.
The reason why we do that is that it's a bad decision.
Yeah.
So numbers that exist in computers are a trade-off, a very good trade-off, but it's a trade-off. And if you've never really spent any minute to try to understand what sort of trade-off, that means that you will be surprised by things where you should not be surprised.
Yeah.
Boom. Well, thank you. I'll push on. So this is for the panel, anyone who wishes. Perhaps Chaaben, I'll speak with you first. Do you think that LLMs, so LLMs, large language models, like ChatGPT, will play a significant role in supply chain?
Well, for instance, what I see is that ChatGPT is more adapted for languages, not for numbers. And if you put a table on ChatGPT and tell it, it's an object, you tell it, give me the average of the table, the average would be wrong. For instance, and for today, ChatGPT is not able really to understand numbers. Maybe in the future this would be the case, but as far as I know, for instance, I don't think that ChatGPT will replace at least a part of the supply chain or people on working forecast or in production or distribution or anything else. This is my point of view. Maybe in the future, yes, maybe ChatGPT would be updated and integrate such techniques and maybe to handle numbers.
And
Joannès, your take?
I have a very different take, for completely different reasons. So I completely agree first. I completely agree with the idea that you cannot feed tabular data to ChatGPT and expect anything. This is a textual model. So if you put tabular data in, garbage out. Period. Okay. Now, so first, the people who are doing the forecast and whatnot, that can be automated. Lokad already does it with numerical recipes. So this part is gone. So I would say
not in ChatGPT.
Sorry?
You don't...
for that, no, those numerical recipes, no. But, as I said, what is the part that remains? So the part that is about doing the forecast and whatnot, that, at least with Lokad, it's already gone. So now the question of the future of supply chain. So first, when people project the future of supply chain, they would think the same thing that they are doing today with better tools. That's not how it's going to happen. The future of supply chain is that everything, all the sort of inventory managers, category managers, demand planner, supply planner, etc., when Lokad is in place, all of that is already gone. So and I'm talking about future, I'm talking now. So those things, so if we think about the LLM, it's not about the LLM to do the job of those things, of those people, because those people are already gone. That would mean, who are the people who are left? They are not the planners. They are what Lokad calls supply chain scientists, because those numerical recipes, they need people to engineer.
Yeah.
And the way you engineer all those recipes is with coding skills, programs.
Yeah.
It has to be programmed somehow. And Lokad, by the way, do it with its own programming language, but supply chain, so if you want to craft those numerical recipes, they have to be crafted with programs. And as I said, the ERP, it's something that is maddeningly complex, 10,000 of tables with 50 to 200 fields. And here, the LLMs are incredibly powerful to speed up this process.
Yeah.
And look at it. So you see, and so my point is, and that's where I think they will play an immense role, an immense
in the
role,
future.
but absolutely not at the level that people think. It will not be to crunch the relational data. It will be to basically gain productivity for the programming activities that will take place for those numerical recipes on top with human supervision. And because people don't realize that there is tons of super mundane things that needs to happen. Just an example. You upgrade the ERP. Out of those 10,000 tables, 700 tables had fields that gets renamed.
Yeah.
And so now you need to propagate those changes across your entire code base. Those are super dumb, but you need to propagate those renames through your entire code base of analysis to propagate everything down to the dashboards that gives you the
And
final.
you need LLM for that?
Yes, because the problem is that the situation is messy. Sometimes they will move a field from a table to another. Sometimes, if it was clean, if it was a clean situation, yes, you could have it's the tools that we're using are called static analysis.
Yeah.
So when you have like a clean rename, you can propagate the change all the way through a code base. But the problem is that, again, this is enterprise software. Usually situations are messy, and you can't really propagate because the things are unclean. They do things that are not very sensical. For example, they remove a field and they introduce two.
Yeah.
And you will have to choose between one and the other. And the choice is not very difficult, but it requires a little bit of automation. And if you can have this automation and maybe have the user being prompt to clarify a few things, then you can rewrite entire code bases.
Yeah.
Again, not magic, but as a productivity tool, it will have like a
but
huge
for
potential.
instance, as it is ChatGPT, you cannot use it directly for.
No,
like,
I mean directly. First, the user interface of ChatGPT is just a web app.
Yeah.
But the things, that's where I say fundamentals matter. LLMs are completion models. So it's
Yeah.
a sequence that takes tokens input
Yeah.
and produce tokens output. So this thing, and I think that was a big surprise with OpenAI, that a model as simplistic as that is super powerful. It is.
Yeah.
So my take is that if you want to think about those LLMs, just think of it as a raw primitive, sequence of token in, sequence of token out.
Exactly.
And forget about the user interface of ChatGPT. This thing is not what you would use. And by the way, Lokad is already using those sort of LLMs, but we use the raw primitives, not the web interface. I mean, the web interface is nice when you want to just ask ChatGPT what is the capital of Argentina or whatever.
Yeah.
But if you want to automate that in an actual supply chain, you need to go through the API and the raw token completion capabilities.
Yeah, just one point maybe for LLM. As the name said, ChatGPT, generative pre-trained transformers.
Yeah.
And you can look at what means transformers, which is an encoder and decoder. As you said, if you look at the technique used in these transformers, you can use them for something else, like maintenance. If you would like, for example, to know what is the remaining lifetime of an engine, for example, in NASA or any other company, you can use transformers that speed up the time to obtain this prediction and give you a more robust optimization and remaining shelf life value. So again, we go back to this algorithm, the transformers, not use it directly for languages, but for something else.
Yes, transformer architecture is interesting, but you see, these sort of use cases about predictive maintenance, for example, they are like very fancy. They will want to make the news. I've basically almost never seen anything, put in production and be actually used, even when people publish case studies.
Yeah.
Case studies are bogus. They claim things that are not true. By the way, for the audience, if you see a case study of a company that says they have saved €500 million of using fancy technique X or Y, you can rest assured that it's bogus and it's just not true. This is just vendor infomercial. But back to the question about transformers, the challenge that I see is that, just to be real for this audience, most companies have ERPs with 10,000 tables and they can't even get the stock level rights. I will not give names, but out of the companies, public companies that I've quoted, that have more than 200 auditors to compute their stock levels, half of them that we have ever worked with, ever at Lokad, had the stock level that they were given to the public, just for because they're public companies, so they have to say every quarter how much inventory they have, was completely off, like off by more than 10%, and we are talking of billions. So the reason, so I'm saying that most companies cannot get a picture of their current stock level within 10%.
What is the reason of that? I mean,
it's the IT landscape is a mess. People think that stock is just a table with SKU quantities. That's what you will find in supply chain textbooks. It's absolutely not like that. In a supply chain, it's super complex. You have stuff that is in transit. You have stuff that have been borrowed. You have stuff that has been leased.
Yeah.
You had agreement to give back stock to suppliers. You have stocks that are suppliers that send you some stuff, but contractually they still own the stuff.
Yeah.
It's very difficult. And so and usually the interesting thing is the reason why Lokad was able to know that, for example, it's because unlike auditors, they just stamp the thing and say, it's correct, trust us.
Yeah.
Lokad, we take decisions. So if the number that we think about the stock level is incorrect, what happens is that we generate the incorrect replenishment decision. And thus we get real world feedback. You know, that's what I said about, for example, discovering the optimization function. You do not know the optimization function. You need real world feedback to know this stuff. So if you do not have real world feedback, you don't know. And that's the problem, is that, for example, people would think about fancy stuff like predictive maintenance, but they don't realize that most of the stuff they don't even know. For example, they would think, they know the price of the stuff they buy. They don't. Because the stuff they buy is an ad hoc negotiation that happens over and over.
Yeah.
So whatever price was when you purchased last time is no guarantee that it will be the same next time. And when you have inflation, people have big surprise. They think, oh, we are going to be profitable. And then they pass an order and they realize that the supplier has raised their price of 10%. Completely predictable. But thus, in this simplistic model, they had forgotten to take into account that most likely every single supplier would raise their price.
Yeah.
You see, that's why I say approximately correct trumps exactly wrong every single time. It's because it's better to have like a heuristic that across the board say all the purchase prices are slurp going to increase by 10% next year. You know, just pessimistic view. That's better than something super fancy like predictive maintenance that just say, oh, we do this super fancy calculation, and then you just miss something that is like an elephant. You see, that the thing that's in those case studies they miss is that people discuss a fancy case study and then people just waste an immense amount of money. Just again, for example, take the Lidl. Lidl, the large European retailer, they publicly announced just a few years back that they had wasted for an inventory optimization project with one of my competitors €500 million just in software development fees. This is just insane. €500 million for an inventory optimization. So yes, people say we cannot afford AI and whatnot. They say, yeah, but you see that the sort of things.
Yeah.
And it keeps happening in the world of enterprise software. So yeah, my take is that the basics are not even really covered right now. Supply chains are digitalized, yes, but they are nowhere near anything that would qualify as optimized or even rationalized. Very frequently, it's not even rationalized. I'm not talking about optimization.
Okay, thank you.
Well, that covers all the questions from the live chat. So I'm mindful of time as well because we started late. So with that, I think we'll draw things to a close. Joannès, thank you very much for your participation. Ling, thank you for the presentation. Professor Chaaben, thank you for arranging all of this. And thank you all for watching. See you next time.